Hey everybody, Matt Morgan here. In this lesson, we're going to talk about orbital diagrams from section 6.4 in OpenStax. We'll talk some more about electron configuration rules. We did the Aufbau principle last time, but today we'll go on to the Pauli exclusion principle and Hund's rule. We'll talk about electrons and spin, and then finally do some example orbital diagrams.
We talked about the Aufbau principle in the last lesson. That said that electrons occupy the lowest energy orbitals first. That gives us the order of the electron filling series for our configurations. In this lesson, we'll move on to the Pauli exclusion principle. This involves electron spin. It tells us that two electrons in the same orbital must have opposite spins. Another rule involving spin is Hund's rule. It says that the lowest energy configuration has the most parallel spins. We'll explain what spin is here in a minute in terms of electrons, then we'll work some examples of orbital diagrams, and we will see these rules in action. So what do they mean by electron spin? I mean, electrons are subatomic particles, and they behave as much like waves as particles, so how can something that small actually spin? Well, it turns out that they don't. They don't really spin like a top, but they behaved like charged objects that do spin. They exhibit properties of a charged object that spins. So, for lack of a better term, I mean, we know that they behave like quantum bodies as well. We just say, okay, electrons spin. And they have two distinct spin states. We call these spin up and spin down. And those are the properties that we refer to when we talk about the Aufbau principle and Hund's rule. So orbital diagrams, they tell us about the electron spin. They tell us about the electron orientation along with where those electrons can be found. The electron configurations, which we did last time, are useful, but the orbital diagram provides us with more information. Let's draw some orbital diagrams, and we'll see our three rules in action. We'll start with nitrogen. Nitrogen has 7 electrons. We set up our orbitals, the 1s, 2s, and 2p. We start with our first electron, spin up. The second electron must be spin down. The Pauli exclusion principle says that electrons in the same orbital must have opposite spins, and we designate this by an arrow pointing up and an arrow pointing down. That tells us opposite electron spins. So 2 electrons down, 5 to go. In the 2s orbital, we'll go spin up, spin down. In the 2p, we start with spin up. Now, where does the next electron go? Will it pair up like the s orbitals? Remember Hund's rule. Hund's rule says that the lowest energy is with the biggest number of parallel spins. The 2p orbitals are equal in energy. So rather than double up and have opposite spins, our last 2 electrons will have parallel spins, but will be in the different p orbitals. This is Hund's rule. We have different orbitals, parallel spins. Of course, this means that the p orbitals are all the same energy. So before we start doubling up, we will go in parallel spins in the different p orbitals. So this is our orbital diagram for nitrogen, showing that there are 3 unpaired electrons. There are 7 electrons total, 3 with parallel spins. Let's do another example, silicon. We found the electron configuration for silicon in the last lesson. We know that silicon has 14 electrons. Its electron configuration is 1s2, 2s2, 2p6, 3s2, and 3p2. Now what does this look like in an orbital diagram? Okay, we set up our diagram. There are orbitals. Let's start populating those orbitals with electrons. 1s2, opposite spins. 2s2, opposite spins. In the 2p, we'll go parallel spins. Once all of the p orbitals are occupied, now we will go opposite spin and fill those. Okay, there are 2, 4, 6, 8, 10. We've got 4 electrons to go. We'll pair up in the 3s orbital. Now we have 2 more electrons in the 3p, 1 electron spin up, and we will follow Hund's rule and draw our second electron in the p orbital spin up as well. And that is our orbital diagram for silicon. Every element that has an electron configuration, you can also draw the orbital diagram. It takes a little bit longer, but it does provide more information.
We went through some more of the electron configuration rules. We talked about orbital diagrams and the more information that they give us compared to the electron configuration. We worked some examples, did some orbital diagrams. If you have any questions about Chapter 6 or any chemistry topic, here's how to contact me. There's my email. We have online office hours Tuesday and Thursday mornings, 9 to 10 a.m. And you can make an appointment if those times don't work for you.